Hi, my name is Addison Talbot from Centerville, Indiana, and my project title is Mask Up. Research topic: Rationale. During the COVID-19 pandemic of 2020, wearing a mask became a way of life. The Center for Disease Control stated that there is increasing evidence that cloth-based coverings can keep people who are infected with COVID-19 from spreading the virus to uninfected people around them. This scientific research investigates the effectiveness of popular masks in preventing the spread of airborne particles during a sneeze. Question: which type of mask will be most effective in preventing water droplets from being spread during a simulated sneeze? Hypothesis: if different facial masks are tested for effectiveness in preventing the spread of water droplets being sprayed during a cough or sneeze, then the cloth mask will prevent the distance of droplets best, because cloth masks have multiple layers, creating greater protection. Procedures: first, collect all of the materials, then build an air cannon to simulate a cough or a sneeze. Then, drill a hole in the foam head's mouth and place the nozzle of the air cannon through it. Put the bolts through the ears to be used to secure the mask to the sneeze simulator. Next, use an anemometer to calibrate the air cannon to release a puff of air at 10 miles per hour. I found that in my research that other researchers found that 10 miles per hour was the closest thing that they could get to a sneeze. Use the same pounds per square inch found to be needed to create the puff during each trial. Next, use a syringe to place 5 milliliters of green water into the mouth of the sneeze simulator. Then, place a clean sheet of butcher paper on the table under the assembled sneeze simulator. Next, fire the cannon with no mask. Measure the furthest particle of water that the butcher paper found that was on the butcher paper from the mouth of the simulator, going straight out and perpendicular. Next, repeat steps 5 through 7 for the N95 mask, gaiter, bandana, paper mask, cloth mask, and no mask. And then repeat trials 3 times with unused masks. Compare data collected. Visual description. Here are 4 pictures of me actually doing the project. And the first picture is the construction of the air cannon for the sneeze simulator. The second picture is me calibrating the airspeed of the sneeze simulator with an anemometer. Anemometers are typically used to find the wind speed of different things. But in this project, I used it to find the airspeed. The third picture is a completed and calibrated sneeze simulator with the foam head attached. The fourth picture is the completed sneeze simulator with the bandana in place. And you can see me in the background, and I'm actually writing in my logbook. Results graph. This is my results graph, and it shows the average distance that the water droplets were measured forward from the mouth. And no mask had 87.2 inches. N95 mask actually had 0 inches, 18.8 inches for the neck gaiter. Bandana had 9 inches, and 1.2 for the paper and cloth mask. Here's my second results graph, and it shows the distance for the spread measurement from left to right for the water droplets from the mouth. And from now on, we're going to call this the outward spread. 18.8 inches for no mask, 0 inches again with the N95 mask. The neck gaiter had 16.2 inches, the bandana had 5.5 inches, and 1.5 for the paper and cloth masks. Results summary. Both graphs show similar results. The N95 outperformed all other masks. It averaged a forward and outward spread of 0 inches. The cloth and paper masks also performed well. Both masks had a forward spread of 1.2 inches and an outward spread of 1.5 inches. The bandana and the neck gaiter did prove better than not wearing any mask at all, but did not perform as well in comparison. The bandana had a forward spread of 9 inches and an outward spread of 5.5 inches, while the neck gaiter had a forward spread of 18.8 inches and an outward spread of 16.2 inches. The control variable with no mask had an average spread of 87.2 inches and an outward spread of 18.8 inches. And if you look to the left, you can see a picture of one of my trials, and this is the trial, one of the 3 trials with no mask, and you can see the average distance and the average outward spread. And right below the picture, you can see a results chart link, and that results chart link will take you to my results charts, and it is a results chart PDF form, so you can look at that. Conclusion. The hypothesis was incorrect because the N95 mask performed better than the others. But that's okay because the cloth and paper mask also performed well in limiting the amount of spread during a sneeze or a cough. The 2 providing the least amount of protection were the bandana and the neck gaiter. I have proven that any mask is better than no mask at all. Furthermore, we have also proven that the N95 mask offers the most protection. Despite the hypothesis being incorrect, we have gained important scientific knowledge on the effectiveness of the use of masks to help contain the spread of germs. Further research could be done to see if mask fitting and placement could change the effectiveness of a mask. So mask fitting would be if it's tight or if it's loose. And the placement would be if it's below your nose, above your nose, only on your nose, etc. The recent trend of wearing two masks could also be tested for its effectiveness. This research emphasizes the importance of wearing a mask to prevent the spread of airborne particles that could spread disease. Knowledge of this can help protect society and save us. Bibliography. Here's my bibliography. My bibliography is where I found all of my research for my research paper. Which mask will you choose?